Good morning. So today we are going to see the topic is mesh analysis. What is mesh analysis is? Mesh analysis normally used to find the current in the circuits. So what are the steps in the mesh analysis? The first step will be for a given circuit we need to identify the number of closed paths there. After identifying that closed path, so we need to name that closed path and also assume the current flow direction in clockwise. After assuming the current flow direction, we need to apply the Kirchoff's voltage law for individual loops. So the second steps will be we need to apply the Kirchoff's voltage law for each loops. Right? What Kirchhoff's voltage law states that means the summation of the voltage rise will be equal to the summation of voltage drop. If in your circuits, suppose current source is there means whether it is shared between the two meshes means we form the super mesh. The final step will be for from the each loop we will get a three or we will get equations. By solving these equations, we will find the voltages and current. So let me take an example of this circuit. Here the question is asked is we have to find the current flows through the 5 ohm resistor by using mesh analysis method. Here we can see that the 5 ohm is there in the middle loop. So as I told earlier, so in this circuit we need to identify the how many closed paths is there. So here this is the first closed loop path, so and current will be assumed as I1, and this is the second closed loop path, and we have to assume the current in the clockwise direction. This current will be I2, and this is the third loop, so the current direction will be in clockwise direction, we are assuming that, and this current will be I3, we are assuming. So now we identify that there are three closed pathway is there in this circuit. So this we consider as a left side closed loop path. This is a right side closed loop path. This is a middle side closed loop path. So from this what we inferring that the current flows through 5 ohm resistors they are asking. So from this assumption what we inferring that this is a 5 ohm resistor which is belongs to the second loop, that is middle loop. Here the current flow will be I2. So we have to find the what is the current flows through this 5 ohm resistor, that is which is equal to I2 value. So now we proceed with the second step. So we identify that how many loops it's there and we assume the current flow direction. So now we are going to find the KVL. We are going to apply the KVL for each loop. From this we will obtain the equations. So first we will see the left side loop. So this is the identified loops, or otherwise we call as a mesh. So the first left side loop, what they are mentioning this, see which includes the 20 volt power supply and 3 ohm and 2 ohm. The current is assumed as I1. So which is what already we discussed in the previous slide. Now, so this is a first thing. So in first loop we are having only 20 volt, and we are having a one resistor is there, and one more resistor is there. This voltage is 20 volt. So this resistance is 3, this resistance is 2 ohm. So this is 3, this is 2, right? So this 2 ohm is shared between the first loop and the second loop. So we are going to apply the KVL. So the voltage drop will be there in this 3 ohm resistor as well as 2 ohm resistor. So the current we are assuming is I1, but in 2 ohm resistor the current will be current is shared between the two loops, so I1 and I2. So for this loop we assume that I1 is positive and I2 is negative. So from this we are obtaining this equation. So this will be marked as the equation number 1. Now we go to the second loop. So as I told you earlier, here in second loop only we are having a 5 ohm resistor. So the current flows through this resistor will be I2. Here we have one more resistor is 2 ohm. It is shared with the first loop, and 3 ohm resistor is there. It is shared with the third loop. That is what is second loop is. So this is the our 5 ohm resistor. This is 5 ohm resistor. Here we have one more resistor. Here also we are having a one more resistor. Okay. So this resistor is shared with first loop and second loop. So this resistor is shared with second loop and third loop. So that is what they are we have mentioned in this line. So here we are applying the uh, KVL. So the current so here all the voltages will be in a drop stage. So that's why this side is voltage drop, this side is voltage rise. So from this what we are obtaining is this equation is obtaining, we are obtaining this equations. Okay, so this equation we will mark it as 2. So similarly we will apply the KVL for third loop also. So in third loop we are having only this is the third loop, one voltage source and two resistor is there in this. So this is 6 ohm, this is 3 ohm. Here 3 ohm is shared with the third loop and the second loop. So here we are consider that the current I3 will be positive while finding the voltage drop across this third resistor. We need to assume that the I3 will be positive. So from this what we will get is final expression will be here, the small correction is there. So this value will be minus 20, minus 3I2 plus 9I3, which is equal to minus 20. This will be marked as equation 3. Okay, so these are the 3 equations we obtained. Okay, so we go for a, so we here we have a 3 equations. We have a 3 unknowns. What are 3 unknowns means? I1, I2 as well as I3. So in second equation only we having a I1, I2, I3. But in first equation and third equation we have, it doesn't have a 3 values. So suppose here we don't have a I3 means we will assume that it will be 0. Here I1 is not there means we will assume that this will be 0. So here we have a three equations, three unknowns are having. So by solving three equation, three unknown method, so we will get I3 value will be 4.07 amps, I2 will be 0.163 amps, I3 will be minus 2.17. So I1 is 4.07, I2 is 0.63 amps, I3 is minus 2.17. Here, what does minus indicate means? We assume that current is in clockwise direction. So suppose minus indicate means we assume the clockwise direction, but actual current in the circuit will be opposite that what we assume that. So our problem is we have to find what is the current flow through 5 ohm resistance. As we discussed in the first slide, the current in the 5 ohm resistor will be the current flow will be I2 value. So we found that what is I2 will be 0.63 amps. Thank you.